Welcome to a lesson with Dr. Powell. Let's suppose that we have a recursive formula for a sequence, such as a sub n plus 1 is equal to the square root of 8 a sub n plus, or minus, rather, minus 15. Okay, so now looking at this, let's ask a question. This sequence right here, is it increasing or is it decreasing? What does that mean? That means as I go further in the list, are the numbers getting higher or are the numbers getting lower? And how can we tell? Let's draw a little graph. Let's plot a sub n plus 1 against a sub n. Against different values of a sub n, what happens with a sub n plus 1? So this is like current to next. So this is not really a graph of the sequence itself, but this is still a graph that can help us see a number of things on how we're going from current to next. Because isn't that what this is? Are the numbers going up? That means from one point in the list to the next, have we gone upwards? Is the next number higher than the last one? So this really comparison should tell us a lot here. Let's kind of draw a dotted line. This is the line y equals x, or in this context, where a sub n plus 1 is equal to a sub n. So if we're on this line, that must mean that to get from one spot to the next, we're kind of stabilized. In fact, if we ever get to this line, we've actually come to a limit of our sequence, meaning our sequence is stabilizing and we can't move from it. For instance, let's suppose, for instance, that we get to this line at some point. And how do we get to the next one? Well, on this particular line, a sub n plus 1 is always equal to an. So to get to the next one, we stay there. And then we're still there. So we follow the same rule and we stay there and we stay there and we stay there forever. So we've kind of, if we ever hit or get close, hit this line, we can't get away from it and we're stuck. So that's just one thing to notice and think about. Another thing to think about, what happens if we're over this line? That means that a sub n plus 1 itself is bigger than a sub n, which means that currently between these two, we are, it's increasing, at least between those two elements, like we've gone upward from where a sub n was to where a sub n plus 1 is. Likewise, if we're down here, it means we're decreasing. Since a sub n right here looks like it's bigger than a sub n plus 1. So a sub n plus 1 is smaller and is small. So a sub n plus 1 is smaller and a sub n is bigger. And then a sub n plus 1 is the next one. And since it went bigger to smaller, then it must be decreasing. So this will give us some insight into this question of whether the sequence is increasing or decreasing. We can go ahead and graph this. Okay, so let's think of this, first of all, it's just on the side. Y is equal to the square root of 8x minus 15. Now, this is just a transformation of the graph y equals square root of x, which, this looks like that, right? Now, what we've done is we've replaced this x value with 8x minus 15. So quite literally, if we just have the graph of y and x, right, we could just kind of say we're replacing x itself with 8x minus 15. So really, if we just think about these values as being 8x minus 15 values, we got the graph of this if in this way, in this picture. Now, using that idea, see, this is x equals 0 right here, at least in the original graph, but now it's going to be 0 equals 8x minus 15. In other words, the vertex or pinnacle point happens when this inner part right here is equal to 0. So we can solve for x here, and we get 15 over 8. So maybe we can say 15 over 8 is right here, and that would be like the pinnacle point. And then we have a parabola. Now, or kind of on its side, that is. This is the parabola on its side going that way. Now, does this always stay below or does it cross? Actually, in this case, it's going to cross. It's going to cross at 2 different points as it goes up. Those points are going to happen, and this picture is a little skewed, but they happen when x is equal to 3 and 5, or in other words, when a sub n is equal to 3, and when a sub n is equal to 5. Okay, so we got 3 and we got 5. Now, when do we know when this is actually increasing, decreasing? Well, it looks like up here, it would be increasing. In fact, you can even picture what's happening. As we come along here, let's think about this. How do we get to the next guy? So let's suppose that a sub n is something right here, so bigger than 3. A sub n is something right, a sub n is right here. So to go to then go to the next point, we go up, and that's the next place on the graph. Then, then what do we do? Then we take this point, and we need to see how this point refers down here to be an a sub n value. How do you do that? Well, to get what value that is, you just go to this line, or they're the same, and then you put it down here. So that's the next value of a sub n plus 1, right? So it's kind of like you go here, and that's the a where it is, and then you plug that into the graph, and you get something here. So it's kind of like going up, making a staircase, going like this and this and this. It's going to stay, and it looks like it's going to head this way and even stabilize and even limit to that point. So it looks like the graph above, using a staircase thing where you always go to y equals x, then you go up to the curve y equals x to curve, y equals x to curve, y equals x to curve. It looks like it's increasing. Just as we suspected here, it's increasing if we're above the line. So if at any point a sub n happens to be, in fact, I didn't even give you a base value, right? So maybe this could be like, so depending on the base value, where we start really depends on what's going to be happening. If we start right here, we're increasing. What if we started up here? What would happen if we were over there? Let's kind of investigate that idea. What would happen if we were beyond it over here? Let's just suppose we're going up this way. All right. So then what we would do, you start here. Remember the sequence. You go from point on to from curve to y equals x to curve to y equals x to curve to y equals x. It looks like we're decreasing, right? Okay, so every time, in fact, you can even see this, the values of a sub n. So the values of a sub n are actually these values right here, like the x coordinates. What's happening to the x coordinates? The x coordinates are going this way, just right here. In fact, it was kind of a misnomer when I put an arrow that way. It really should have been an arrow going this way. When the values of x are going this way, it's increasing. When the values of x in this staircase idea, we go y equals x curve, y equals x curve, and so forth. When the values are going this way, then what's happening? It's decreasing. So if at any point a sub n happened to be over here, or the x coordinate happened to be over here. So if we start out, so a sub n is bigger than 5, then it's going to be decreasing toward 5. If a sub n is between 3 and 5, it looks like we're going to be increasing to 5. Now, what about if this particular case, let's think about if we were down here. So following the pattern, what do we have? We go y equals x to, oh, well, we don't really have, well, if we try this, we don't really have anywhere to go. So maybe that wouldn't even be, let's see, if we were on the curve, right? So if we had an a sub n value right here, I mean, let's even think about that. I mean, even if we started here, what would happen? If we put in 15 over 8, we would have a value of 0. And then we try to put in a value of 0, and we get something undefined. So that wouldn't, you notice how we're not really even getting to the curve anymore, it's not defined. So that actually doesn't even work. So if we started here, went to curve, that still wouldn't work. In fact, yeah, we might just run into troubles kind of over in this area. So if we want our sequence to actually get closer to something, it looks like we'd want our values to start or kind of be between 3 and 5 or be bigger than 5. It looks like they're always going to be heading toward 5 in just looking at this particular picture. Thanks for watching.